Hello AP Statistics students. In this video, we are taking a look at measuring the variability of a distribution. The last video was all about the center. Now we're talking about the spread. So how spread out is our data? So our objective here, we will describe the variability or spread of a distribution using three methods: the range, the interquartile range, and standard deviation. And remember, this is all part of a complete description of a distribution, which we abbreviate SOX for shape, outliers, center, and spread. So we are looking at the spread or the variability. All right, the one we already know, the range. It's where you take the maximum and then you subtract off the minimum. All right, nice and easy. So quick example here one more time. 11 high school students were asked how many close friends they have. Here are their responses along with a dot plot. So there are their responses. Here is our dot plot. What is the range? So we take the maximum, which is 6. So our range is 6 minus the minimum, which is 1. So our range here is 5. Now, you have to interpret that. So what does this mean? All right. So the range of context, close friends in for the 11 students we asked is 5 friends. Ooh, let me move that over. All right, the range is 5 friends. It does have units, so I'll even add that right here. 5 friends. It is a single number, the number 5, and so in your sentence you want to report that single number. Now, the pros and cons for the range. There is one main con for the range. I mean, the pro is that it's easy to find. All right, you just take the biggest and subtract the smallest, so it's easy. That's your pro. But the con is it is not resistant. We've talked about resistance a little bit. I don't remember if resistant has 1 or 2 S's, sorry. It is not resistant, meaning outliers affect it a lot, okay? Not resistant to outliers, okay? All right, the next way we can do spread is the interquartile range. This one we haven't talked about much. So what's the vocabulary here? What's a quartile? What's an interquartile range? Let's talk about it. So quartiles, they will divide your data into 4 equal pieces, okay, when you use the median. So let's say you have your data. I'll just use a big bar here to sort of metaphorically describe our data. The median, of course, is in the middle. It breaks the data in half. Okay, the quartiles break those two halves in half. And you can see now my data has 4 equal pieces. We call this one Q1, and we call this one Q3. Okay, and those 3 lines break our data into 4 equal pieces. So let's say we asked 20 people a question. Okay, our median breaks it up into 10 on the left and 10 on the right. And then our quartiles would break it up into 5 people there, 5 people there, 5 people there, and 5 people there. So those Q1 and Q3 help break our data up into 4 equal pieces. I know it's word Q3, you think 4 pieces of Q3, that sometimes confuses me, but figure it out, sorry. Now, the interquartile range, the word range hopefully cues you that we're going to be doing a max minus a min, but not the entire max and min, the quartile max and min. So the inner quartile range is you take Q3 and you subtract Q1, okay? That gives you this range right here. And the important thing there is when you find Q1 minus or Q3 minus Q1, that gives you the middle 50% of your data. So if I again ask 20 people, the middle 10 people are between Q1 and Q3. That is the inner quartile range. So pros and cons here. So the pro is that this is a resistant, it does only have one S, measure of spread. All right. Outliers do not affect it. Because we're cutting off the outside, we're not talking about the far left or the far right. You know, politics is bad. We are not affected by outliers. This is a resistant measure of spread. I guess the con could be it's a little harder to calculate, but not that big of a con. It's not that hard to find. And I'll show you how to find it in a specific example right now. But the main thing is it is a resistant measure. Outliers do not affect it. All right, let's actually do one here. So boys and their shoes, am I right? How many pairs of shoes does a typical teenage boy own? To find out, 2 AP Statistics students surveyed a random sample of 20 male students from their large high school and recorded the number of pairs of shoes that each boy owned. Here are the data along with a dot plot. All right, so there is our data. We got our dot plot, looks good. Looks like we might have some outliers over here to the right. And if you neglect those outliers, our shape right here is pretty symmetric as long as you don't count the outliers. All right, but how do we find the inner quartile range? So first, we order the data. So do you see how the data is least to greatest? Once you do that, the median is really easy to find. We asked 20 male students, so we got to have 10 numbers on the left and 10 numbers on the right. Because that's even, there is no number in the middle, and so we have to find the number between 8 and 10, which is easy, is 9. All right, so that's the median. Now for our quartile 1, Q1, and Q3. So we basically just find the median again. We've got 10 numbers on the left, split it in half, 5 and 5, which means we have to go between the 5th and 6th number, which is 6.5, and the same thing on the right, 1, 2, 3, 4, 5, between the 5th and 6th number gives us our Q3, which is 11.5. Then you subtract the Q3 minus Q1 to find that our inner quartile range is 5 pairs of shoes. So the inner quartile range for these 20 male students is 5 pairs of shoes. Okay, all right. Let's try one that isn't already done for us and actually do the work. So here are the data on the highway fuel economy ratings for a sample of 25 model year 2018 Toyota 4Runners tested by the EPA, along with a dot plot. So here's the data. Sadly, it's not organized. Here's our dot plot of that data. So you can see hopefully the shape roughly symmetric. I'm seeing some outliers possibly on the left and the right. Now let's talk about the spread. Find the range of the distribution. All right, so the range is the min minus the max. Sorry, the max minus the min. There we go. So our maximum is right here. So that's 23.123, 23.3 minus the min, which is 21.123. 21.5. So that gives us our range, which is going to be what? 21.5, 22.5, 23.5 would be 2. So that is 1.8. Now it has units, 1.8 what? Miles per gallon. We're looking at fuel efficiency rating. So context, context, context. All right. The range of fuel economy for 2018 Toyota 4Runners in this 25 vehicle sample, all right, is 1.8 miles per gallon. Again, do the math, and then you have to interpret what your answer means in context. All right, we got the range. We're going to skip number 2, the mean and standard deviation. I'm saving that one for last. Number 3, find the inner quartile range of the distribution. All right, so to find the inner quartile range, a little bit more math, we've got to keep splitting this data up. So there's 20, I believe it was, 25 models. So I got to find the median. So if I have 25 models total, I'm going to have 12 on the left, 12 on the right, and then in the middle there'll be one piece of data. That'll be my 13th piece of data. Now, I could order these numbers from least to greatest and write out all the numbers and then find the 13th. But I can also do that from the dot plot fairly easily. So I'm going to count to the 13th dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. My 13th dot is right here. That is the median, and so that is 22.4. So my median is 22. This is number 3. The median is 22.4. But for IQR, the inner quartile range, I need Q3 minus Q1. So now I'm going to break these 12s up in half as well. So that's going to be 6 and 6. So that's an even number, the 12 is. So there's not going to be a data point in between. So I have to figure out what is between the 6th number and the 7th number. So the same thing is going to happen over here. The 6th number and the 7th number I have to figure out for Q1 and Q3. So I'm going to count over 6. 1, 2, 3, 4, 5, 6 is this one. The 7th one, oh, they made that easy on me. There is nothing between those two. It's the same number. So that's 22, 22.1, 22.3. So Q1 is 22.3. Sorry, 22.2. What am I saying? Now Q3. I'm going to start from the middle and count over 6 again. So 1, 2, 3, 4, 5, 6. Between the 6th and the 7th is right here. Oh, they made it easy on us again because those are the same number. So what's between 22.6 and 22.6? It is 22.6. All right. So now my interquartile range, you can abbreviate IQR, is 22.6 minus 22.2. So if I subtract those, oh, that's nice and easy. That's just 0.4 miles per gallon. All right. All right, see if you can write a sentence like this for the IQR. It's going to sound almost exactly the same, so I'm not going to write it, but maybe pause the video and write that sentence in context for the interquartile range. All right, I assume you did that. So standard deviation now, our third measure of spread, okay? This is the weirdest one. but it's also in many ways the most important. So the standard deviation is this magical number that is the typical distance data points are away from the mean or the center. Probably want to write that down. Think of it as an average, even though you don't want to use the word average. It's on average, how far away is data from the middle? Okay, that helps you measure spread. I'm not going to do the calculation in the video. It's a very long, tedious calculation. We are going to do it in class, maybe once or twice, and you will gain something by doing the calculation. I think it will give you a better understanding, but that takes too much time for right now. I want to get you the very basic and general idea and write some sentences. But is the typical distance away from the center. So if you have a large value of standard deviation, and we call it S sub x, the standard deviation of our variable, x. If you have a large S of x, that means your data is very spread out. Data is more spread out. All right, because the typical distance from the center is bigger. And if you have a smaller standard deviation, the data is, of course, less spread out. So the interpretation is really the important thing here. Once you're given the standard deviation, and once we do it twice by hand, the calculator is always going to find standard deviation for us. It's extremely tedious to find, but it's a very useful number, and computers can do tedious really well. So once we have the standard deviation, what does it mean? So here's our sentence frame. The blank, all right, that's our context, is typically blank away from the blank. All right, now what do we put in those blanks? The first blank is your context. What are you talking about? What does your data mean? Is typically blank away. How far away? Well, that is your standard deviation, whatever number that is, away from the, well, it's the typical distance away from the center. So whatever your mean or middle is. So that's kind of the sentence that we want to be able to write, or some variation of that. All right, the pro and the cons of this. The pro, it's a very important number that tells you a lot about your data. All right, tells you a lot about the spread of your data, which is amazing. The con is it is not resistant to outliers. So just like the range, the standard deviation is not resistant to outliers. Because you are finding the typical distance of all data points away from the mean, you're also factoring in the distance of outliers, the ones really far away from the mean, and that can skew the standard deviation and make it look bigger than maybe the data actually is. So it is not resistant to outliers. All right, let's do one of these and practice writing that sentence. So we're back to the Toyota 4Runner question, and we have the dot plot, we have the data, and so here they're not making us calculate it, they are telling us the mean and standard deviation of the distribution are 22.404 miles per gallon and 0.363 miles per gallon respectively. Interpret the standard deviation. So I'm going to use that sentence frame, and just like in English, if you remember, they always tell you to restate the prompt. Same thing in stats. Always restate the prompt and you will sound like a genius. So the highway fuel economy for these 25 2018 Toyota 4Runners typically varies by 0.363, so that's how much we're on average away from the middle, miles per gallon away from the mean of 22.404 miles per gallon. Let me stretch that out, make it look a little nicer. So let's deconstruct that sentence. So this is our context here. The highway fuel economy for these 25 2018 Toyota 4Runners. I just copied that from the sentence. And now here's what the standard deviation means. It means those numbers typically vary by this much. This is how far away they are from the middle. Typically. Where is the middle? Away from the middle of 22.404 miles per gallon. Again, I've got units, I've got context. All right, now number 4. Which measure of variability would you choose to describe this distribution and explain why? So we got 3 options. Do we want to use the range? Do we want to use the interquartile range? Or do we want to use standard deviation? Which one gives us the most accurate view? Well, we look at this nice picture of the dot plot, and like I said at the beginning, it looks like 2 outliers, one on the right and one on the left. So hopefully the 2 outliers get rid of range as an option, because those 2 outliers are really affecting the range, the max and the min, and range is not resistant. But then I can use that same argument against the standard deviation, because the standard deviation is also not resistant to outliers. So that paints a picture that this number is probably too big to really represent our data well. So what we want to take a look at is the interquartile range. The interquartile range is the best option because this data has an outlier on the left and an outlier on the right. So we don't want to use the range or standard deviation because they are not resistant to outliers. Done and done. All right, so that's all I've got there. Measures of spread, we've got the range, the IQR, and standard deviation now. In class, we will look at how you actually calculate the standard deviation, but hopefully now you've got an idea for what it actually is.